Folks, welcome back, and we are continuing to draw electron dot pictures. Now, I've done the first 11 elements for you. Let me do another one for you, and let me have you pause the video after I do that and try a few on your own. So let's start today with the element magnesium. You can see that it is atomic number 12, so it means it has 12 electrons. It's in group 2, so it has 2 valence electrons. And its dot picture would be magnesium, the symbol for magnesium. And remember, the first 2 are always paired. So we'd say that magnesium has 1 pair of valence electrons, and this is its dot picture. Okay, now, why don't you pause the video and try doing aluminum without my help? I'll bet you'll be able to do it. When you're done, go ahead and press play again, and we'll see how you did. See you on the other side. All right, welcome back. So aluminum, of course, is atomic number 13. That means it has 13 electrons. It also happens to be in group 13, coincidentally. So the last digit in the number 13 is 3, so it has 3 valence electrons. Should we draw that orbital diagram again just to prove that? So if I drew the nucleus for helium, and the first energy level can hold 2. Second energy level can hold 8, so there's 10 of my 13. Don't I have to go to the third energy level? And it would have 3 valence electrons. Once again, do you notice that aluminum happens to be in the third period or third row of the periodic table? And it has 3 energy levels. Wow, coincidental. It also happens to be in group 13. It has 3 valence electrons. Now, in a later chemistry class, you're going to learn why that's not coincidence. But for now, I think just understanding that it has 3 valence electrons and being able to draw its dot picture is adequate. So we have aluminum. Remember, the first 2 are paired, and then we have 1 unpaired electron. Why don't you try doing silicon and phosphorus now? I think you've got this, don't you? So pause the video, try silicon and phosphorus, and then we'll come back and see how you did. All right, we're back. Silicon, atomic number 14. So it has 14 electrons. It's in group 14, coincidentally. It has 4 valence. And so its dot picture, silicon, has a pair, and then it has 2 unpaired electrons. Phosphorus, atomic number 15. It has 15 electrons. It also is in group 15. The last digit in group 15 is a 5, so it has 5 valence electrons. So phosphorus has a pair, and then 1, 2, 3 unpaired. Isn't that interesting? I think it's also interesting to note at this point in our video that phosphorus's dot picture looks remarkably similar to another element that we've done recently. Take a look at phosphorus's dot picture and nitrogen's dot picture. Do you notice their dot pictures are the same? Yeah, they are. Do you also notice that they're in the same group? That should make sense. They're both in group 15. They have the same number of valence electrons, so it would make sense they would have the same dot pictures. And if you think ahead a little bit, think about the next element in that group, arsenic, and then antimony and bismuth. Yeah, they'll probably have the same dot pictures, won't they? All right, well, let's go to the next page and let's do a few more elements, shall we? Let's move on to sulfur. So sulfur, kiddos, is atomic number 16. It is also happens to be in group 16, so it has 6 valence electrons. So its dot picture would be a pair, and then we'll go 3, 4, 5, 6. So it looks like there are 2 pairs of valence electrons and 2 unpaired electrons for sulfur. By the way, if you look at the previous page for your dot picture for oxygen, you will notice that oxygen and sulfur have the same dot pictures. Of course they do. They're in the same group. Oh, don't we call groups families? They're in the same family. They are similar to each other. Okay, next up is chlorine. Chlorine is atomic number 17, so it has 17 electrons. It happens to be in group number 17, so it has 7 valence. And so when I draw its dot picture, we have a pair, and then we're going to go 3, 4, 5, 6, 7. So chlorine has 3 pairs and 1 unpaired electron, just like fluorine. Argon, our next noble gas. Its atomic number is 18, so it has 18 total electrons. It's in group 18. It has 8 valence electrons. So when I draw the dot picture for argon, kiddos, I have 1, 2, 3, 4, 5, 6, 7, 8. Hey, look at that. It has 8 valence electrons, just like neon did a little while ago, and we like to say 4 pairs. Now, it turns out that having 8 valence electrons or 4 pairs of valence electrons is very stable. And what that means is that element is unreactive. All noble gases are unreactive. They all, except for helium, have 4 pairs of valence electrons, you'll see, and it ends up to be a very stable electronic configuration, to where the atom does not react with anything at all. Or at least it's very hard to get it to react with anything at all. So there's something very special about the number 8 and having 4 pairs of valence electrons. You'll notice in my classroom on the ceiling, I like to hang 4 pairs. Oh, that's not a good picture of a pear. Let's see if I can draw it there. I like to hang 4 pears from my ceiling. You know, the fruit. And the reason I hang, let's try to make that look like a pear. The reason I hang 4 pears from the ceiling of my classroom is because it's sort of funny. It reminds everybody when they walk in my room that 4 pears represents stability. So I like to hang 4 pieces of fruit from my ceiling, 4 pairs. Sort of funny. All right, let's move on. Potassium, you might be worried because now it has 1 more electron than argon. We're up to 19, and you might be worried about where that next electron is going to go in the dot picture, but don't fear. Everything will work out. It has 19 total electrons. It's in group number 1, kiddos. It has 1 valence. Isn't that interesting? So if I were to draw the orbital diagram for potassium, you would see that it would have 4 energy levels. It also happens to be in period number 4. It has 1 valence electron. It also happens to be in group number 1. So when I draw the dot picture for potassium, I am back to 1 dot. Okay? Now, why don't you take the next couple of minutes and let's go all the way from calcium through krypton, kiddos. See if you can do that without my help. Then when you're done, press play again and we'll see how you did. Ready, set, go. All right, welcome back. Let's go through these a bit faster. It's starting to be busy work, isn't it? Calcium has 20 electrons, 2 valence electrons. So its dot picture has just a pair. We're going to skip over to gallium now. So we're going to skip what's called the D block or transition metals for right now in this class. So we're going to go to gallium, which has 31 electrons. Did you make that shift? Yeah, it's in group 13. So even though it has 31 electrons, it has 3 valence. And so its dot picture is Ga with a pair and 1 by itself. Germanium has 32 electrons. It's in group 14 with 4 valence. And so germanium's dot picture is going to be just like carbon's dot picture, isn't it? And just like silicon's as well. Arsenic, atomic number 33. So 33 electrons. It's in group number 15, so 5 valence. And so we have arsenic with 1, 2, 3, 4, 5. It has 1 pair and 3 unpaired valence electrons, just like phosphorus and nitrogen. Selenium, its atomic number 34, so 34 electrons. It's in group 16, so 6 valence. So its dot picture is 1, 2, 3, 4, 5, 6. So 2 pairs and 2 unpaired. Just like sulfur and oxygen, by the way. Bromine, next up, atomic number 35. So 35 electrons in group 17. So 7 valence. So bromine has 1, 2, 3, 4, 5, 6, 7 dots, 3 pairs, and 1 unpaired. And here we are, kiddos. We get to our next noble gas, atomic number 36. 36 electrons, group 18, so 8 valence. And so Krypton has 4 pairs of valence electrons. Hey, what do we know about that? When we have 8 valence electrons, we like to say that that's 4 pairs, because aren't all 8 electrons paired up? And we know that that's very stable. It's a stable electron configuration. 4 pairs of valence electrons. You notice all noble gases, except for helium, have 4 pairs of valence electrons. Of course, helium doesn't, because it only has 2 electrons, so it can't get up to 4 pairs. All right, kiddos, I think you got this. We'll see you soon. Bye-bye.